Welcome to another deep dive from the Rooster Podlog. Today, you're joining us for what I think is a genuinely fascinating exploration. How to really get the most out of those advanced AI models we're seeing everywhere.
Yeah, it's a big topic right now.
It really is. Think of it less like issuing commands and more like, well, learning a subtle but powerful language that unlocks their true potential for you.
That's a great way to put it. And for you, our listener, who's likely bumped into AI in all sorts of contexts, maybe at work for some creative projects, or just out of sheer curiosity, this deep dive is tailored to give you that insider knowledge.
Mm-hmm.
We want to help you consistently get insightful and accurate results without feeling like you need, a computer science degree.
Exactly. We've been digging into a comprehensive guide on something called prompt engineering. Now, that might sound a bit technical, but honestly, at its heart, it's really the art and science of crafting effective instructions for AI.
Right. It's about how you ask.
And to make all these ideas stick, we're going to use something super familiar, Legos.
Oh, Legos. Perfect.
Hmm.
Think about it this way. Just like you can build incredibly detailed and complex structures with Lego bricks if you know the right techniques and put them together thoughtfully,
Right.
you can get amazing outputs from AI if you construct your prompts in a smart way.
Mm-hmm.
We're going to unpack a whole toolbox of these prompting techniques,
Okay.
explain what each one is, and show you how it relates back to our Lego building analogy. Our mission today is to give you those aha moments and practical skills so you can confidently and effectively interact with AI.
Okay, sounds good. So let's get our hands on some virtual Legos and start with the most basic technique, zero-shot prompting.
Right.
Imagine we just dump a big pile of assorted Lego bricks in front of you and say, okay, build a car. No picture, no instructions, just go.
Right. In the AI world, zero-shot prompting is very similar. You give the model a description of a task or maybe a question without providing any specific examples of what the output should look like. It's relying purely on all the knowledge it has absorbed during its training. It's just figuring it out based on what it already knows.
And the guide has a great illustration of this. It says, classify movie reviews as positive, neutral, or negative, and then it gives a review. Let's look at the one for Her. It says, Her is a disturbing study revealing the direction humanity is headed if AI is allowed to keep evolving unchecked. I wish there were more movies like this masterpiece.
And the AI, using zero-shot, correctly flags this as positive.
Right, even with that word disturbing in there.
Exactly.
Hmm.
Now, the interesting thing here is that even though the review uses a word like disturbing, which can, have negative connotations,
Sure.
the AI understands the overall sentiment, especially with that concluding phrase, masterpiece,
Yeah.
and the wish for more such movies. It's accessing its broad understanding of language and sentiment to perform the classification.
So it's looking at the whole picture.
Precisely. The key takeaway here is that zero-shot is fantastic for quick, straightforward tasks where the AI's general knowledge is sufficient. However, if you need more nuanced or specific output,
It's like building a very particular model of car.
exactly, then you might need to provide a bit more guidance.
Absolutely. Which leads us nicely to our next level of Lego instruction, one-shot and few-shot prompting.
Okay.
Now imagine we show you one picture of a specific Lego car, maybe a sleek sports car, and say, build something like this. That's one shot.
One example.
Or we show you pictures of 3 or 4 different Lego cars, a truck, a sedan, maybe that sports car again, and say, build another car based on these designs. That's few shot.
Exactly. In the AI world, this translates to giving the model one or several examples of the kind of output you're hoping for.
Okay.
This acts like a template, sort of helping the AI understand not just the task, but also the desired format, style, or even the underlying pattern it should follow.
Right, so it sees what good looks like.
Pretty much. Our guide mentions that around 3 to 5 examples is often a really effective starting point for few-shot prompting. It's considered a highly effective practice, actually. What's happening under the hood is something called in-context learning. The AI isn't being retrained or anything permanent. Instead, these examples are temporarily influencing how it processes your current request and shapes its response for that interaction.
Ah, I see. Okay, let's dig into that pizza order parsing example from the guide. That sounds useful.
Yeah, it's a good one.
The initial prompt asks the AI to parse a customer's pizza order into valid JSON. Now, for you, our listener who might not be super familiar with it, JSON is just a way of structuring data in a clear, organized format that computers can easily understand.
Like having a specific way to list the Lego bricks you need for a particular section of your build, a structured parts list.
Perfect analogy. So the prompt sets the task, translate natural language into this structured JSON format. Then we get our first example. I want a small pizza with cheese, tomato sauce, and pepperoni.
Uh-huh. And here's the corresponding JSON response the example provides. JSON.
Small.
Cheese, tomato sauce,
Okay,
pepperoni.
fair enough.
Yeah.
Size, type, ingredients in a list. Then there's a second example. Can I get a large pizza with tomato sauce, basil, and mozzarella?
And the response for that one is
Large.
That's-
Tomato sauce, basil, mozzarella.
got it. So slightly different ingredients, different size, same structure.
You can see how these examples act like mini instructions, right? They show the AI how to identify key pieces of information from the text, like the size and the ingredients, and how to structure them within that JSON format. Notice the square brackets for the list of ingredients.
Right. And now here's the new order we want the AI to parse. Now, I would like a large pizza with the first half cheese and mozzarella, and the other tomato sauce, ham, and pineapple.
A tricky one. A half and half. Let's see what the AI does, learning from those two simpler examples. Here's the JSON output it generates, .json.
Large half?
Cheese, mozzarella, tomato sauce, ham, pineapple.
Wow. Okay, so it figured out the half-half type.
Yeah.
And made two separate lists for the ingredients.
Isn't that neat? What's really impressive here is how the AI has learned from just those two initial examples to handle this more complex order. It's understood there are now two distinct sets of ingredients, one for each half, and it's structured the JSON accordingly.
Yeah, that's really powerful.
It's a fantastic demonstration of how providing just a few well-chosen examples can really guide the AI and enable it to generalize to new but similar situations.
Like showing someone a couple of finished Lego vehicles,
Mm-hmm.
and then they can figure out how to build maybe a slightly different type of vehicle,
Yeah.
even if it wasn't one of the specific examples.
Exactly that.
Okay, moving on. Let's talk about system prompting. This sounds foundational.
It is, yeah. Think of this as setting the stage before you even start reaching for your Lego bricks. It's like saying, okay, everyone, today we're only building vehicles, and we can only use red and blue bricks. Oh, and every vehicle must have wheels. These are overarching rules that apply to everything you build from now on in this session.
Got it. Setting the ground rules up front.
That's a perfect analogy. In the AI context, a system prompt is a set of high-level instructions that tells the model how to behave throughout your interaction. It sets the overall context, the purpose of the conversation, maybe rules or constraints it should follow before you even ask your main question.
So it could be about tone or format.
Exactly. Should it be formal, casual, enthusiastic? What format should it use? Maybe enforce certain safety guidelines or ethical considerations. It's like giving your Lego builders a clear brief before they even open the box.
Our guide revisits the movie review classification to illustrate this. The system prompt this time is, classify movie reviews as positive, neutral, or negative. Only return the label in uppercase.
See that last part? Only return the label in uppercase. That instruction isn't about the content of the review itself. It's a rule about how the AI should format its answer.
Right, a formatting constraint. Then we give it the Her review again. Heron is a disturbing study revealing the direction humanity is headed if AI is allowed to keep evolving unchecked. It's so disturbing I couldn't watch it.
Now, as we discussed earlier, the sentiment here is a bit ambiguous, isn't it? Someone might focus on couldn't watch it and think it's negative. The user's feeling seems complex. However, because of that system instruction, only return the label in uppercase, the output is simply negative, all caps.
So it followed the formatting rule strictly, even if the underlying sentiment was maybe more complicated.
Exactly. This shows how system prompts can enforce a specific output format or behavior, overriding maybe a more nuanced internal analysis. It's like our master Lego architect who, even if they had a brilliant idea for a yellow accent on their red and blue vehicle, is strictly bound by the initial rule to only use those two colors. They follow the system prompt.
Okay, that makes sense. Now, let's dive into role prompting. This sounds fun.
It really is. This is like telling our Lego builder, all right, today you are a pirate, and your task is to build a treasure chest.
How high?
Or maybe you are an astronaut and you need to construct a spaceship. Suddenly, their entire approach, the kinds of Lego pieces they might favor, even how they might talk about their creation will be influenced by that assigned role.
So you're giving the AI a persona.
Precisely. When you assign a specific persona or identity to the AI, you're essentially activating a different set of its knowledge, a distinct communication style, and potentially different goals within the model. It's like telling it, think like this kind of person or this kind of expert.
And that shapes the response.
Dramatically.
Right.
It influences the tone, the style, the depth of knowledge it draws upon, and ultimately the overall behavior of its response.
The guide gives a great example of this with the travel guide. The prompt is, I want you to act as a travel guide. I will write to you about my location, and you will suggest 3 places to visit near me. In some cases, I will also give you the type of places I will visit. My suggestion, I am in Amsterdam, and I want to visit only museums.
That initial phrase is key. Act as a travel guide. That signals to the AI to access its information about travel, tourism, Amsterdam, museums, and, critically, how a helpful travel expert would communicate.
Right, and the output. It suggested the Rijksmuseum, the Van Gogh Museum, and the Stedelijk Museum, Amsterdam. Pretty spot on for Amsterdam Museum.
Exactly. And look at the descriptions provided. They aren't just one-liners. They give you a little taste of what each museum offers, like mentioning Rembrandt's The Night Watch at the Rijksmuseum.
Right.
It really feels like you're talking to someone who knows their stuff about Amsterdam Museum.
Yeah, the persona comes through.
The AI has adopted the persona and provided relevant details and context that a typical travel guide would offer. This is incredibly useful for tailoring the AI's response to a very specific need or audience.
So you could ask it to act like a physics professor for a technical explanation.
Or a fantasy writer for a creative story. It's all about leveraging that role to get the specific flavor and content you're looking for. Think of our pirate Lego builder suddenly being much more interested in brown and gold bricks and maybe even incorporating some skull and crossbones into their treasure chest design. The role changes everything.
Cool. Okay, next step is contextual prompting.
Right. This involves giving the AI specific background information that's relevant to the task you want it to perform.
So more info up front.
Kind of. Imagine someone is building a Lego house and you add, oh, and remember, this house is for a family with 2 dogs, so it really needs a backyard and probably a doghouse.
Okay. That extra bit of context helps them tailor their build in a much more useful way. Without the dog info, they might just build a standard house.
That additional information is absolutely key. Knowing that detail allows them to incorporate specific features that cater to the needs of the clients, in this case, the family with the dogs.
The guide provides an example of writing for a blog about retro 80s arcade video games. The prompt asks for 3 article topics with descriptions. The crucial piece of context here is right at the beginning. You are writing for a blog about retro 80s arcade video games.
That context immediately focuses the AI's thinking. It understands the specific niche, the target audience, likely people interested in nostalgia and classic gaming, and the kind of content that would be relevant and engaging for that specific blog.
And the AI delivers perfectly. The suggested topics are the evolution of arcade cabinet design, blasts from the past, iconic arcade games of the 80s, and the rise and retro revival of pixel art.
Yep.
And the descriptions for each clearly fit that retro arcade theme. For instance, the description for Blast from the Past specifically mentions the history, impact, and legacy of some of the most beloved titles.
See, it's using the context.
This really highlights how providing relevant context can significantly narrow down and refine the AI's output, making it much more targeted and useful for your specific needs.
It's like telling our Lego builder that the house they're designing is meant to be in a very snowy climate. They'd probably think about adding a steep roof to prevent snow buildup, maybe some extra insulation in their design. The context changes the requirements.
Got it. Now we're getting into some of the more strategic prompting techniques you said. Let's talk about step-back prompting.
Yeah, this one's interesting. Instead of directly asking someone to build this very specific Lego spaceship Model X, you first ask a more general question like, what are the key principles of building really sturdy and cool-looking Lego spaceships?
Okay, why do that?
Well, once they've thought about those principles, stability, aesthetics, whatever, then you ask them to build Model X, keeping those ideas in mind. It's like activating the right knowledge first.
I like that approach. It's almost like getting the foundational knowledge in place before tackling the specific task.
Yeah.
Like understanding the basics of Lego construction before trying to build something complex.
Exactly. In the AI world, this involves first prompting the model with a broader, more abstract question that's related to your ultimate goal. The idea is that the AI's answer to this step-back question will help it access and activate relevant knowledge and understanding,
Hmm.
which it can then use to address your original, more specific request in a more informed, maybe more creative way.
The guide uses an example from the world of first-person shooter video games. The initial step-back question is, based on popular first-person shooter action games, what are 5 fictional key settings that contribute to a challenging and engaging level storyline?
Right. The aim here is to get the AI to think about the fundamental elements that make a good and engaging FPS level before it even attempts to create one specific storyline.
Okay, so it's priming the pump, sort of.
You could say that. This broader perspective can often lead to more creative and well-reasoned results in the subsequent task. The AI might suggest settings like an abandoned military base, a cyberpunk city, or an underwater research facility.
Right. Then, the original task comes with this context. Context, list of settings from step 1. Take one of the themes and write a 1-paragraph storyline for a new level of a first-person shooter video game.
See? By providing the AI with those potential settings that it itself just generated, you're guiding it to create a storyline that hopefully aligns with established and successful elements of the genre it just thought about.
Ah, okay. So the first step helps the second step be better.
That's the idea. This demonstrates how that initial broader question helps the AI generate more informed and creative responses for the specific task you had in mind. It's like asking our Lego builder about the fundamental principles of spaceship design, maybe aerodynamics, structural integrity, cool aesthetics, before asking them to build that specific Model X. Their understanding of these underlying principles will likely lead to a better, more well-thought-out final product.
Now, let's talk about chain of thought, or cut-to prompting. This technique encourages the AI to essentially show its work. Is that right?
That's a perfect way to put it. Think of it like asking our Lego builder to narrate their process out loud. Okay, first I'm going to lay down this big base plate. Then I'll add these 4 corner towers. Next, I'll connect them with these long wall pieces.
And why is that helpful?
Well, that narration of the building process forces the builder to think sequentially and logically. It also helps ensure they don't miss any crucial steps, and it allows you, the observer, to understand their reasoning along the way.
Okay, so how does that work with AI?
In the AI world, chain of thought prompting involves explicitly asking the model to generate intermediate reasoning steps before it gives you the final answer. You can often trigger this by adding simple phrases to your prompt, like, let's think step by step.
Ah, okay. Just ask it to think it through.
Pretty much, and it's particularly useful for problems that require multiple logical steps, calculations, or a bit of careful reasoning where mistakes can easily happen if you jump straight to the answer.
The guide provides a classic age riddle to illustrate this. When I was 3 years old, my partner was 3 times my age. Now I am 20 years old. How old is my partner? Let's think step by step.
Notice that last little phrase in the prompt. Let's think step by step. That's the signal, the trigger, that tells the AI to engage its chain of thought process.
Right. And the output it generates literally shows the steps, doesn't it?
Yeah, it does.
Yeah.
It shows the AI's reasoning step by step. 1, when I was 3, my partner was 3. 3 equals 9 years old. 2, the age difference between us is 9. 3 equals 6 years. 3, now I am 20 years old. 4, my partner's current age is my age plus the age difference. 20 plus 6 equals 26 years old.
Okay, that makes the logic completely transparent. You can see exactly how it got to 26.
Exactly. You can actually see the AI's line of reasoning as it arrives at the answer. This technique is incredibly powerful for tasks that require logic, arithmetic, or multi-stage reasoning because it makes the AI's thought process transparent and helps to ensure the accuracy of the final answer, much less likely to make a simple calculation error.
It's like our Lego builder explaining each stage of constructing a complicated castle, making it much easier to spot if they make a mistake or if their logic doesn't quite hold up.
Precisely.
Okay, building on chain of thought, we have self-consistency. It sounds related.
It is, very much so. Imagine you ask 5 different Lego builders to build a bridge using the exact same set of somewhat vague instructions. Because the instructions are vague, they might all come up with slightly different designs or use slightly different construction techniques.
Right, there's some ambiguity.
Exactly. Self-consistency is like looking at all 5 of those finished bridges and seeing which specific design elements or techniques appear most often across all of them. The idea is that the most common approach is likely the most reliable or effective one.
So majority rules, basically.
In a sense, yeah.
Yeah.
Because large language models can sometimes produce different reasoning pathways, even for the same question, especially if you allow for a bit of randomness in their output generation, which is controlled by a setting often called temperature. Self-consistency leverages this natural variability to try and improve the reliability of the final answer.
So how do you actually do that?
In practice, the guide explains that this involves prompting the model multiple times with the same question. And crucially, for each attempt, you also ask it to use chain of thought to explain its reasoning.
You get multiple answers, each with its own step-by-step logic.
Exactly. You then look at all the different final answers you get across those multiple attempts and see which one appears most frequently.
And you pick that most frequent answer.
And the idea is that the answer that is most consistently arrived at, even potentially through slightly different reasoning paths, is more likely to be the correct one. It's like our 5 Lego bridge builders. If 3 of them independently decide that using a particular type of triangular support beam is crucial for the bridge's stability, then that design element is probably a sound and effective choice.
Gotcha. Using consensus to improve accuracy.
You got it.
Now, tree of thoughts, or 2TT. This sounds even more complex.
It definitely takes this idea of exploring different reasoning paths to another level. Think back to our Lego Technic model, maybe something really complex with gears and levers.
Okay.
You might get to a step where there are 3 or 4 different ways you could potentially attach a particular gear assembly. A human builder might try one way, realize it won't mesh properly with a later step, so they backtrack.
Right. Happens all the time with Legos.
Then they try another way that looks more promising, and maybe even briefly consider a third option before settling on the best one. Tree of Thoughts allows the AI to explore multiple potential reasoning paths more or less simultaneously, like exploring branches of a tree.
So it's not just one linear path like chain of thought.
Exactly. Instead of following a single linear chain of thought, the model maintains a kind of tree structure in its mind. Each node in the tree represents a thought or a step in the reasoning process, and from each node, it can branch out and explore different possible next steps.
And it can go back if a branch doesn't work out.
Yes, it can evaluate whether a particular branch is leading towards a viable solution and backtrack if it hits a dead end or seems unpromising. This is particularly well suited for tackling very complex problems that might have multiple potential solutions or require significant trial and error in the reasoning. Problems where just one path might not be enough.
The guide doesn't give a super simple text-based example for this one, does it?
No, it's harder to illustrate concisely with text, but we can kind of imagine how it would work for a really intricate logic puzzle. The AI might explore several different initial assumptions, and if one assumption leads to a contradiction down the line, it can go back up the tree to the point where it made that assumption and try a different branch, a different starting point.
Like our Lego Technic builder, not just sticking with the first idea they have for that gear assembly, but actually trying out a couple of different configurations in their head. Or maybe even physically connecting the pieces briefly to see which approach feels the most promising and stable before committing to it.
That's a good way to think about it, exploring multiple possibilities concurrently.
Okay, next. React, which is short for reason and act. This sounds different again.
It brings in another really interesting dimension, yeah. Imagine you're building that Lego model, and you realize you're missing a key piece of information. Say, you're not sure how a particular wing is supposed to attach based on the diagram you have.
Okay.
You might think, reason, okay, I need to figure out how this wing goes on. Then you take action, act, by maybe searching online for a video tutorial or looking up the specific part number on a Lego database using an external tool. You observe the result. Ah, that's how it connects. And then you use that new information to continue with the next step of your build, reason again.
So it's not just the AI reasoning internally, it's also about it being able to interact with the outside world or use specific tools to get information it needs.
Precisely. React combines the reasoning capabilities we saw with things like chain of thought with the ability to take actions using external tools. These could be web search engines, code execution environments, calculators, maybe access to databases or APIs.
How does that cycle work?
The model thinks about what it needs to do, reason, decides on an action that could help it get that information or perform a necessary step, act. It then executes that action, observes the result, observe, and uses that observation to inform its next thought and action. Reason, observe, reason. It's an iterative process.
So it can go beyond its training data.
Yes, that's a huge advantage. It allows large language models to go beyond the limitations of their internal knowledge and access up-to-date or very specific information to solve problems they couldn't handle otherwise.
The guide's example of how many kids do the band members of Metallica have is a perfect illustration of this, right? Because that info changes.
Exactly. The AI likely doesn't have that specific real-time information perfectly memorized in its training data. So we can see its thought process. It realizes it needs current info, reason. So it takes action. It decides to perform individual web searches for each of the current band members' act.
Like search. How many children does James Hetfield have?
Right. It observes the results of those searches, updates its internal knowledge for that specific interaction, and then continues this reason, act, observe process for each member until it has gathered the information needed to provide the final synthesized answer.
So it's that back and forth flow.
Yeah.
Thinking, I need info on Lars Ulrich. Acting, search for Lars Ulrich children. Observing, search result says X children. And then thinking again, okay, got Lars, now need Kirk Hammett.
You've got it. This showcases how AI can actively engage with the real world, or at least digital tools accessing it, to retrieve information it wasn't directly trained on. This allows it to answer a much wider range of questions and perform more complex, grounded tasks.
It's like our Lego builder who, upon realizing they don't have a particular rare brick they need for the roof, might temporarily pause building reason, go search through their other Lego bins, or maybe even look up online Lego Marketplaces Act, observe what they find, found one, or nope, got to change the design, and then adjust their building plan accordingly. Reason again.
Excellent analogy. That's the core loop of React.
Moving on, we have chain of draft, or code. This sounds like a quicker version of chain of thought.
That's basically the idea, yes. Think about when you're building something with Legos, maybe following complex instructions. You might just jot down very quick, concise notes to yourself about the key steps or connections, like maybe just blue 2x8 gray base, instead of writing out a full detailed sentence like, I am now attaching the blue 2x8 brick onto the center of the large gray base plate.
Right, just the essentials.
Exactly. Code is all about efficiency. It recognizes that sometimes a full, verbose explanation of every single step in the reasoning process, like in classic CoT, isn't really necessary and might actually be computationally wasteful, especially if the task is relatively straightforward or the intermediate steps are simple calculations.
So it uses fewer words, fewer tokens.
That's the goal. By using these very minimalistic intermediate reasoning steps, often just keywords, short phrases, or maybe just the key calculations involved, it aims to reduce the total number of tokens used when interacting with the large language model. This can lead to faster processing times and potentially lower costs, as many models charge based on token usage.
The guide compares Kali with Claude using a simple lollipop problem. How does that look?
Right. We see how the chain of thought approach uses full sentences to explain each step of the logic. I started with 20 lollipops. I now have 12 lollipops left. The number of lollipops I gave away is the initial amount minus the final amount, and so on.
Okay, very wordy.
Whereas the chain of draft approach gets right to the core of the reasoning using a much more shorthand, perhaps equation-based method. Instead of the full explanation, call might just note something like initial, 20, final, 12, giveaway, initial, final, 20, 12 equals 8, or even just 20x equals 12 equals 20, 12 equals 8.
Much more concise.
You can see how COD gets straight to the essential logic without the extra explanatory language. It's like our experienced Lego builder who, instead of narrating everything, might simply jot down blue 2x8 gray base. It's a more direct and concise way to represent the process, assuming the builder, or maybe the AI itself for a subsequent step, understands that shorthand notation.
Okay, efficient thinking. Now, automatic prompt engineering, or APE, this sounds meta. AI prompting AI.
It really is fascinating. Imagine you want to get the absolute best set of instructions for building a very specific and intricate Lego tower. Instead of just trying to write them yourself based on your own experience, you ask 5 different highly experienced Lego builders who, in this analogy, are actually other sophisticated AI models to each write down what they think are the clearest and most effective instructions or prompts for building that tower.
Okay, so you crowdsource the prompt writing to other AIs.
Kind of, yeah. Then you compare all the different sets of instructions they come up with and you evaluate them somehow, maybe based on clarity, maybe testing them out, and pick the one that looks the clearest, most comprehensive, and most likely to lead to a successful build, or maybe you combine the best parts.
So APE leverages the power of large language models to help us actually improve the very prompts we use to interact with them in the first place.
Exactly. It's like a meta-level optimization,
Yeah.
using the AI's own capabilities to refine how we communicate with it.
The guide gives an example of a band merchandise web shop. They want to come up with various ways that a customer might order one Metallica t-shirt size S to help train their customer service chatbot.
Right. So using APE, they might ask a powerful LLM, acting as the prompt engineer, to generate, say, 10 different phrasing variations that a real customer might use to place that order.
Like, I need a Metallica T, size S, or can I get one small Metallica t-shirt?
Yeah.
Stuff like that.
Exactly, all those variations. And the idea is that these different phrasings, all generated by the LLM itself, can then be evaluated. This evaluation could involve testing these generated prompts on the actual chatbot they're developing and seeing which ones lead to the correct order information being extracted most reliably and efficiently.
So it's like using AI to fine-tune the way we talk to AI, ultimately leading to more robust and effective interactions, and hopefully better performing AI systems.
Precisely. It's like having a team of expert Lego instruction writers all contributing their ideas on how to best describe the steps for building a particular model, and then you get to choose the set of instructions that is the clearest, most comprehensive, and easiest for anyone or any AI to follow.
Very clever. Okay, code prompting. This seems like a huge area on its own.
It definitely is. It's all about using AI for tasks that are related to computer code. You can think of code as being like incredibly complex Lego structures with very, very precise instructions and rules.
Right, a single misplaced bracket can mess everything up, like a Lego piece in the wrong spot.
Exactly. So code prompting includes things like asking the AI to generate new code for you based on a description.
Like building a Lego bridge that has to be exactly 12 inches long and support a certain weight.
Good analogy. It also includes explaining what an existing piece of code does.
Like understanding how the complex steering mechanism works on a pre-built Lego Technic car.
Translating code from one programming language to another.
Like rebuilding a Lego house you made with standard bricks, but now you can only use Technic beams and pins.
And even helping you find and fix errors in your code, which we call debugging.
Like figuring out why your awesome Lego crane creation keeps collapsing every time you try to lift something.
Perfect. The guide gives examples of each of these code-related tasks using Bash and Python code snippets. Writing a script, explaining a script, translating Bash to Python, and even identifying an error in Python code and suggesting a fix.
So it's really versatile for developers.
Immensely versatile. These examples really highlight how AI can understand and work with code at different levels of abstraction. It can take a high-level description and generate code, help you understand complex logic someone else wrote, bridge the gap between different programming languages, and act like a debugging assistant.
It's like having an AI assistant that can not only design and build Lego models for you based on your specifications, but also explain how existing models work, help you rebuild them using different types of bricks, and even figure out why your Lego creation keeps falling apart and suggest ways to make it more stable.
That covers it really well.
And finally, we have multimodal prompting. This sounds like it goes beyond just text.
It does. This is where you're not just using text to communicate with the AI, you're using multiple types of input, multiple modes.
Okay, like what?
Well, imagine getting instructions for a really intricate Lego model that include not only written step-by-step directions, but also a picture of what the finished product should look like.
The box art.
Or maybe even a short video clip showing exactly how to connect a particularly tricky part that's hard to describe in words or static diagrams.
Right, that combination of different types of information can be incredibly powerful in guiding the building process.
Definitely. So in the AI world, multimodal prompting means using a combination of text, images, audio, maybe video, or even code as input to guide the model, depending, of course, on the specific capabilities of that AI model. Not all models can handle all modes yet.
While our guide today has primarily focused on text-based prompting techniques, it does mention multimodal prompting as a separate and rapidly evolving area.
It's a huge area of research and development.
So, for example, you can imagine showing an AI model an image of a very specific and unusual Lego brick, and then asking it via text, what's the official Lego part number and name for this piece? That would be multimodal.
Exactly. You're combining image input with text input to get the answer. As AI models continue to develop and become more sophisticated, their ability to understand and process these different kinds of input simultaneously will unlock even more powerful and intuitive ways for us to interact with them and leverage their capabilities.
It's like having Lego instructions that not only tell you what to do in words, but also show you exactly what it should look like at each stage of the construction, maybe even with little animations for tricky bits.
That's the direction things are heading.
Wow. Okay, so that's a lot of techniques. As you can see, just like becoming a master Lego builder, becoming truly proficient in prompt engineering involves understanding this whole range of different techniques,
Mm-hmm.
and crucially, knowing when and how to apply them effectively. From the foundational zero shot, prompting all the way to the more advanced stuff like Tree of Thoughts and React, each method offers a unique set of tools for interacting with AI and guiding its responses to get the best possible results for you.
We really hope this deep dive with our trusty Lego analogy, hopefully helping along the way,
Bet you did.
has given you, our listener, a much clearer understanding of these incredibly powerful tools. But remember, the absolute key to really mastering this is experimentation.
Yeah, you got to try it out.
Try out these different prompting methods with the AI tools you're using. See what yields the most insightful and accurate results for your specific needs and the kinds of tasks you're working on. What works for one task might not be best for another.
That makes sense. So maybe think about what kind of AI interactions are you most curious about trying to optimize now? What specific challenges have you encountered when trying to prompt AI in the past?
Yeah, reflect on that.
We really encourage you to think about these questions and maybe even try out some of these techniques we've discussed.
Mhm.
This is truly just the beginning of a fascinating journey into the world of artificial intelligence communication.
It really is.
And the more you understand these fundamental prompting principles, the more effectively you'll be able to navigate it and get the AI to, well, build the amazing things you have in mind.
And as you continue to explore and experiment, just remember that the field of prompt engineering is constantly evolving. New research, new techniques, updated best practices are emerging, like all the time.
So keep learning.
Keep learning, keep trying new things, and you'll undoubtedly continue to unlock even greater potential from these increasingly amazing AI tools. It's an exciting space to be in.